So welcome to the video lecture on signals and systems. This video we will be discussing about analysis of DT systems, and under this we will find how to calculate the output response y of n when the initial conditions are provided. So the basic few points let us discuss first. Now whenever the initial conditions are not given, if you have y of n, that yields y of z on z transform. If you have y of n minus 1, then on z transform it gives you z power minus 1 y of z. Similarly, when you have y of n plus 1, then that on z transform will give you z y of z. Y of n plus 2 will give you z square y of z on z transform. So these are the terms which we have discussed without initial conditions. But when initial conditions are given, we have a separate rule when we apply the z transform. For example, when we have the right shift, that is the delay, x of n minus m u of m, if it is of this form, then on z transform with the initial conditions included, this will be giving you z power minus m x of z plus z power minus m summation n is equal to 1 to m x of minus n z power n. Whenever it is an advanced signal of the format x of n plus m u of n, then that on z transform will give you z power n x of z minus z power m summation n is equal to 0 to m minus 1 x of n z power minus 1. So these two equations will be used to convert the difference equation with the initial condition to algebraic equations. So we have a example here. Never mind, I will give you an easier way to remember these equations. So the question says, consider the following difference equation: y of n plus 2 plus 5y of n plus 1 plus 6y of n is equal to x of n plus 1 plus 4x of n. Now the auxiliary conditions are as follows, which are nothing but the initial conditions. Y of 0 is equal to 1 and y of 1 is equal to 2. The input x of n is equal to u of n. We'll have to solve for y of n. So here we have y of n plus 2 in the difference equation. We have y of n plus 1, we have y of n, we have x of n plus 1 and x of n. So here when we apply z transform to this difference equation, we'll have to make sure that we apply the rule with the initial conditions. So this is not just going to be without initial conditions. Without initial condition, we just transform it. But with initial conditions, we'll have to follow the previous equation, whatever I've told you. So y of n plus 2 on z transform will give you, with the rule applied, z square y of z minus z square y of 0 minus z y of n, which is equal to z square y of z minus, what is y of 0? Y of 0 value is 1. So we get it as z square minus, we have z into y of n, 1, right? So what is y of n? 2. Minus 2 is it. Then we have y of n plus 1. This on z transform will give you, with the rule applied, z y of z minus z y of 0. So substitute the value of y of 0, we get z y of z minus z. Similarly, we have x of n plus 1. So this on z transform with the initial conditions rule applied, we get z x of z minus z x of 0. Substitute the value of x of 0, we get it as z x of z minus z. So here these equation formats, whatever we have seen, y of n plus 2, y of n plus 1 and y of n plus x of n plus 1. Before substituting the y of 0 and y of n values, look at the first expressions. This one and this one. So make sure you by heart these formats so that it will be easier for you to apply in the examination. Then we have x of n is equal to u of n given in the question. So apply z transform to it. We get x of z is equal to z by z minus 1. So we will take z transform to this entire difference equation given in the question. Simply we are going to substitute whatever we have found out so far. So just substitute. We get it as z square minus 5z plus 6 multiplied by y of z equal to z square plus 2z minus 5z plus z plus 4z by z minus 1 minus z. So we have just substituted all the requirements, y of n plus 2, y of n plus 1, x of n plus 1 into this difference equation, and we have got this format. So next thing what we'll have to do is, since we are going to find out the output response, we'll have to get this entire equation in terms of y of z. So just solve it, and we have got the y of z as y of z by z equal to z square minus 4z plus 8 divided by z minus 1, z minus 2, z minus 3. So this z in the denominator, we have had it in this numerator, and we have cross multiplied and to bring it to the form y of z by z, because while we apply partial fractions, it is always required to have it in this format: y of z by z, h of z by z, depending on whatever is asked. So we apply partial fractions technique, a1 by z minus 1 plus a2 by z minus 2 plus a3 by z minus 3. So here you apply z is equal to 1 and you find out a1 value as 2.5. Then you apply z is equal to 2 and a2 value becomes minus 4. We apply z is equal to 3 and we get a3 value as 2.5. So the next step is we'll have to apply a1, a2, a3. We'll have to just substitute it here in this particular major equation, and we get your y of z as, we have already cross multiplied z to the numerator on the other side. We get it as 2.5 z by z minus 1 minus 4 z by z minus 2 plus 2.5 z by z minus 3. So what we'll have to do now? Direct inverse z transform. A power n u of n on z transform gives you z by z minus a. So the inverse we'll have to apply. We have z by z minus 1. So what is this? 1 power n u of n. So we have it as 2.5. Then in the second term we have 4 z by z minus 2. So what is this? 2 power n u of n. So we have minus 4 2 to the power n plus. Then what is the third term? 2.5 z by z minus 3. So what is this? Z by z minus a. A power n u of n. So 3 power n u of n. We have taken u of n as common from the entire term. So this is how you will have to calculate output response for a given system with initial conditions applied. I have another example for you. Solve the following difference equation: y of n plus 2 minus 9y of n plus 1 plus 20y of n equal to 4x n plus 1 plus 2x of n. The inputs are x of n is equal to 1 by 2 power n u of n, and the initial conditions given are y of minus 1 is equal to 2 and y of minus 2 is equal to 1. So here we have the given equation is actually in the advanced format, which actually requires the initial conditions y of 1 and y of 2. But in the given question, y of minus 1 and y of minus 2 initial condition values are given. So what we do is we will convert the entire equation into delay form. So what is given here is in advanced form. So we just bring it in delayed form. So to bring it into delayed form, we will replace n with n minus 2. And we have y of n minus 9y of n minus 1 minus 20y of n minus 2 equal to 4x of n minus 1 plus 2x of n minus 2. So the given input is the causal one. So therefore x of minus 1 and x of minus 2 values are going to be 0. So we will take Z transform for this delayed expression whatever we have got. Now this becomes, I've substituted it directly because in the previous problem I've shown you like what will be the expressions for y of n minus 1, n minus 2, so on. So we will go ahead, we get it as y of z minus 9 z inverse y of z plus 9 y of minus 1. Then we have 20 y of n minus 2, right? So this on Z transform is going to give us 20 z power minus 2 y of z plus 20 z inverse y of minus 1 plus 20 y of minus 2. So how did we apply Z transform here? We have kept in mind the rule for, with initial conditions while applying Z transform. So let's solve this, solve the other end of the equation. We have 4x of n minus 1, right? So this on Z transform will give you 4z inverse x of z plus 4x of n minus 1. Then we have 2x of n minus 2 in the equation. So this on Z transform will give you 2z inverse x of z plus 2z inverse x of minus 1 plus 2z inverse x of minus 2. So we have got it in Z transform format. So the next thing what we'll have to do is we'll have to go ahead and substitute the initial condition values. So we have x of minus 1, x of minus 2 values as 0. And y of minus 1, y of minus 2 values are given in the question. So let's substitute all the values and solve this entire expression for y of z. So when you solve this entire expression for y of z, we get y of z by z is equal to minus 2z square minus 35z plus 22 by z minus 0.5, z minus 4, z minus 5. Keep it in mind, we have also substituted the x of z value, which is nothing but z by z minus 0.5. So how did we get this x of z? X of n was given to us in the question. So we have taken z transform for that and we have got x of z. So for applying partial fractions, we have got it in the form of y of z by z. Now split it in the partial fraction format. a1 by z minus 0.5, a2 by z minus 4 plus a3 by z minus 5. So let's substitute z is equal to 0.5 and a1 value becomes 0.254. Substitute z is equal to 4 to get a2, which is 42.86. Substitute z is equal to 5 to get a3, which is minus 45.1. So substitute the values of a1, a2, a3, also cross multiply the z. So we get y of z as 0.254 z by z minus 0.5 plus 42.86 z by z minus 4 minus 45.1 z by z minus 5. So what is this? Z by z minus a. Which signal it is? A power n u of n. So apply inverse z transform, you get y of n is equal to 0.254 0.5 power n plus 42.86 4 power n minus 45.51 5 power n the whole u of n. So this is how you will have to solve the problems on how to find the output response y of n with initial conditions given. Thank you.